Hey team, this is Mrs. Hunter. All right, so let's look at example B. The hydrogen ion concentration of an aqueous solution is 1 times 10 to the negative fourth molar. What is the concentration of hydroxide? So we are going to use that new formula we learned. This shows us if we know the concentration of hydronium or hydroxide, and remember, sometimes instead of hydronium, we might just say H+, means the same thing. We can always figure out the other. Okay, so I've gone ahead and written that in the corner there. We want to know the concentration of hydroxide, and you'll notice they've given us the concentration of hydrogen. So we can just plug it into this formula. 1 times 10 to the negative 14th equals, so the concentration of hydrogen ions is 1 times 10 to the negative fourth. And that'll be equal to whatever the concentration of hydroxide ions are, which we don't know. Well, that's like your x variable, right? This is like x, solve for x. So if we divide both sides by 1 times 10 to the negative fourth, the concentration of hydroxide is going to equal 1, and I'm going to say 0.0 because I want to mimic the number of sig figs in the original, times 10 to the negative 10th. And again, this will be in molarity. We're solving for concentration. All right, and how do I figure out if the solution is acidic, basic, or neutral? You want to compare the amount of hydrogen versus hydroxide. So go back to this slide. You want to compare the amount of hydrogen to the amount of hydroxide. So let's go back to our problem. In this problem, we have 1 times 10 to the negative fourth. That's the amount of hydrogen we have. And the amount of hydroxide is 1 times 10 to the negative 10th. So remember, we're dealing with numbers in scientific notation. So our concentration of hydrogen is 0.0001. Our concentration of hydroxide, for dramatic effect, 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so which do I have more of, hydrogen or hydroxide? I am hoping you would say we have more hydrogen, and because we have a greater concentration of hydrogen, that means this solution would be acidic. If we took like a pH strip or an indicator, we would test the solution and get an acidic result. So hopefully that helps you solve this, and I've got one more example for you.